Hello again, Javatarians. Today we're going to talk about loops again, but today we're going to talk about the while loop. And in the second video, we'll talk about its cousin, the do-while loop. So the while loop is a loop that iterates as long as some condition is true. So while some condition is true, the loop operates again and again. So again, it's associated with some condition that is tested for truth. And as long as the condition is true, the loop will continue to run the block of code. And each time the block of code runs, it's called one iteration of the code. So the syntax is the word while at the front, and inside the parentheses goes the condition, the thing you're tested for truth. And it checks, and as long as this expression is true, whatever's in between the braces will be executed. Notice, it's different from the for loop, there's no initial value and no increment. We'll see different examples of how that's dealt with in a moment. So let's go to while one. So what do we have here? Well, we take this variable run and we set it equal to 0. And here's our loop with the while. And as long as run is less than 5, we're going to continue adding or running, iterating through this loop over and over and over again. So what does it do? Well, run is equal to 0. So this is true, so we enter the loop. We add 1 to the value of run. We then print it out, so we're going to print the value 1. We hit the end of the code. Well, when we hit the end of a loop, we go back up, just check to see if this is still true. Run is equal to 1, which is less than 5, so we enter again. Add 1 to it, so run is now 2, so we're going to print the value 2. Etc., etc., etc. So when we actually run it, we get 1, 2, 3, 4, and 5. So again, the first time it prints the value 1 because of the increment. It adds 1. Next time, prints 2. Adds 1 again, 3. Adds 1 to get 4. And then adds 1, run is equal to 5. It prints the value 5. Then when we hit the end of the loop, we go back. This is no longer true. 5 is not less than 5. So the loop is over. It stops iterating. That's why there's no more print statement. So again, we started at 0. We increment first and then print. So we get the 1, 2, 3, 4, 5. It works in the negative direction as well. We can subtract just like we could with a for loop. So we're going to subtract 5 each time here. So when I run this, the while 2, what do I get? Well, run is equal to 25 to start with. And since 25 is greater than or equal to 10, we're going to enter the loop, print the value 25, and the word loop. We then subtract 5, run is equal to 20. So this condition is still true, so we print the 20 and the word loop. We subtract 5. 15 is still greater than or equal to 10. So we print the 15 and the loop. Last but not least, we subtract 5 again, run is equal to 10. And we print that last time. Now, then we subtract 5, run is equal to 5. This is no longer true. The loop is done. Another example, the same thing but in the opposite direction, is while loop 3. We start at 10. So we start with run equal to 10 and continue as long as the run value is less than or equal to 25, adding 5 each time. So those of you that are level 4 math super geniuses already know that we're going to get 10, 15, 20, 25, increasing by 5 each time, and continuing for as long as run is less than or equal to 25, stopping once it's greater than 25. So, now, what you've seen so far is really just a for loop, just in 3 separate pieces. So, one thing that you will strongly benefit from is tracing while you're asked about output of a loop. Like I showed in class, write out each step, each increment, each iteration of the loop. Right? In this case, there's only one print line at the end, so you only get one output. But you've got all this internal workings going on while you're running the loop. Get used to writing that out every step, every iteration of the loop. You're not able to do this in your head. Okay, at least I'm not, so I'm assuming you can. Nothing personal. So, but what we've seen is really just a for loop. We're just separating the initialization and the condition and the increment. Yeah, so far is what we've seen. But the thing about a while loop is that it can run for as long as you need it to. Right? It doesn't necessarily have to have a set number of iterations. Right? If you need it to run more flexibly, you just set up the conditions more flexibly. Right? It does not have to have a preset number of iterations like the for loop. It could conceivably run forever, like this one. So the while forever loop. Tell you what, let's just run it first. Okay. The computer has chosen a random number between 1 and 100, and I am to try to guess it. So let's just say 50. Right? My guess is too low. Choose a bigger number. 75. Too high. Choose a smaller number. Okay. And it will continue running until I actually guess the correct value. So let's say 62. Now, I might get real lucky, get it on the first guess. I might be real stupid and get it on the 100th guess. But it will keep running as many times as necessary, or as few times as necessary, until I get it right. Okay. Between 50 and 62, 6, 53. All right, so it took me 1, 2, 3, 4, 5 guesses. Right? Now, I could have gotten lucky, done it in 5. Average for this is about 7. But I don't know beforehand how many times I'm going to run it, so I have a while loop here. That's the flexibility of the while loop. It'll run as long as I need it to. It doesn't necessarily have a preset number of iterations. So let's take a look at the code, just briefly. So I choose this goal, and it's a random number between 1 and 100. And then I take in my integer guess. Now, what I want to do is keep guessing as long as I'm guessing wrong. So the condition on my goal is, while the guess is not equal to the goal, keep asking. And I've got two cases here. If the guess is greater than the goal, right? That's when it prints out my guess is too high and takes in my next guess. If it's less than the goal, my guess is too low. It tells me that and takes in my next guess. And here's where the while loop ends. This will keep giving me these messages as long as I guess something other than that random number between 1 and 100. Eventually I will guess it. That's when I leave the loop and come down. And after the loop is the part about me guessing the number correctly. Again, that is outside the loop. Each time I guess, I get to the end of the loop and I check to see if it's equal to the goal. If it's not, I cycle through again. If it is, I'm done with the loop and I get the glorious message that I guessed correctly. Again, it's flexible enough because I'm not incrementing like a plus plus or minus minus. I'm taking in a new value, so it can run as long as I type in a new value that isn't what I'm looking for. Let's look at another example. Dissecting numbers. I can peel apart the individual digits of a number and look at the individual digits one at a time. I'm going to look at the file accessing digits. So what it does, it takes some number, right? And if I want to look at just the last digit, well, that would be the remainder when divided by 10. So if I took this number, divided by 10, I would get 915 with a remainder of 4. It would be just the last digit. If I want to see the digit next to that, I would just divide it by 10 and do the same thing. Dividing it by 10 would erase the 4. I'd have 915. Then take the remainder. That would be 5. So this remainder on 10 operator tells me what the last digit is because I'm in base 10. Division by 10 peels off the last digit so I can look at the second digit, the third digit, the fourth digit. I move up the number. So let's take a look at this in a loop just to see if this makes a little more sense. Accessing digits. Right. So what am I getting here? Well, so as long as the number is greater than 0, I'll have some sort of remainder when I divide by 10. So so this just makes me stop when I peeled away all the digits, all 4 digits. So what's the last digit? Well, it's the remainder when divided by 10. That's where this 4 comes from here. I then divide the number by 10, and thanks to integer division, I get 915, a nice clean integer. There's no 0.4. And that gets printed out here. So number is now 915. It's greater than 0, so I do it one more time. I find the last digit by the remainder mod 10. That's my 5. I divide 915 by 10. I get 91. I take the remainder mod 10. That gives me a 1. Right? I divide 91 by 10. I get 9. And then I go in one more time. The number is 9. So the remainder mod 10 is going to be 9. And then thanks to integer division, when I divide 9 by 10, I get 0. That's going to get printed out here. The condition is no longer true, so I stop. So each time I divide by 10, I lose one digit. And if I want to see what that last digit is, I take that number with the remainder operator on 10. And if this helps, I have, without so much printing, the individual digits. I take the remainder on 10. It gives me the last digit. I then divide it by 10. So the next time I take the remainder, I get the next digit up. So I'm crawling up one digit at a time. 4519, 4519. So I take it apart digit by digit, which means that I need a loop. But suppose I had another number with a different number of digits. That loop would have to iterate a different number of times. So if I wanted to work on 982365, I need a loop that runs as long as I need to. That's why I'm using a while loop. So while the number is greater than 0, I can keep dividing it by 10. And I get to print out the 4519. Now the next two parts are types of problems you will see a lot down the road. Adding things up, totaling a sum is the first thing. Well, so we can add up the digits. Since we can peel away each digit, we can do that. So we're going to sum up the digits of a number. How do we do that? Well, we add the rightmost digit to the total. First of all, start off with a total of 0. And then as you peel off each digit, add it to the total. So use the remainder operator to find out what the last digit is. And when after you've added it to the total, remove it using division by 10, and that will give you the access to the next digit after that. After you've added all that up, you print out the total. Let's see if code helps make that a little bit clearer. So summing up digits. So what am I doing? Well, again, as long as the number is greater than 0, I take that the furthest right digit, remainder, and I add it to the total, which started off at 0. Again, I'll just use that number, 9154. I identify the rightmost digit. I add it to the total, then I divide by 10, so I'll get to the next digit next time, and my loop knows to stop when I hit 0, when I've divided out all the digits. I'm adding up all the digits as I go through. Total is what gets printed when I'm done. All right. And again, make sure you understand what's going on with this chunk of code. You will be asked to sum up and total up various numbers and functions in many different ways over the course of this course. So make sure you understand what's taking place. You have a total that's set to 0. And then you get an individual term, in this case the rightmost digit, via the remainder operator. Then you add that term to the total, and when you're done, you've added up all the terms that you've seen so far. If you have any questions about this or the next one, taking the average of the digits, make sure you ask me about it. You'll see problems that involve that over and over again through the course. So, counting digits. Right? Well, this is just how many digits are there. When you divide by 10, add 1, because you've taken away one digit. And when you make it through the loop, count. That total count will be how many digits you've peeled away. That's how many digits are in the number. What are we doing here? Well, we're going to add up the digits and divide by how many digits there are, get the average value. And these two types of counters, this total and this number of digits, make sure you understand how this works. So I've structured this a little bit differently. I've separated the two pieces of code. So I've got this function that counts the number of digits in a number. How do I do that? Well, I take my loop. I remove one digit by dividing by 10. Num digits is how many digits I've seen so far. None before I get into the loop. I just took one away, so I add 1 to the number of digits. I keep doing this until I get to 0. I add 1 each time I divide by 10. Num digits at the end. At the end of the loop, after it's done, num digits will be how many digits I've peeled away. Sum digits, summing up the digits. Well, again, I have a total up here that starts at 0. I identify the rightmost digit with the remainder. Each time I identify that digit, I add it to the total. Divide by 10 so I can get to the next one. And whatever I've got at the end of the loop is the total sum of all the digits. And how do I calculate the average? Well, no surprise. I sum up the digits. I divide it by how many digits there are. That will be my average. So again, I broke it into 3 different methods here, just as a more object-oriented approach. And hopefully so you can see individually what's going on. When I'm counting the digits, I'm just adding 1 at a time because I'm counting 1 digit at a time. But when I'm totaling, I'm adding the terms themselves. When I find this term, I add the term to the total. Okay. Different processes. Make sure you see the difference and understand them. You'll be asked to do that a lot. add it up. Okay, I'll tell you what, let's do 1, 2, 3, 4, 5 as my number. The average digit is 3. If I took 1, 2, 3, 4, 5, they add up to 15. Divided by 5 would be 3.0. So again, make sure you understand the totaling and the counting of the digits. You will have to write methods like that all the time. All right, some common errors. Yes, things you'll do wrong. Right. Leaving the loop blank. If you have no change in the run value, you have an infinite loop. Beware the infinite loop. So that's all for today. There is another video about the do-while loop. You'll watch that next. But what I want you to do first is to work on the Check for Understanding worksheet, just to make sure you understand the mechanics of how a while loop works. Thanks very much for listening and watching. See y'all in class.